So, all right, we are recording. So today we're going to be talking about study methods specifically for science-based courses. So BMS 300 is definitely one of those courses. And we're also going to be talking more than anything about test-taking strategies, how to approach your exams, how to tackle Dr. Walleran's questions with process, and hopefully that will help you guys do a little bit better and be more confident on these exams, okay? So I did this workshop with Abby on Wednesday. Oh, I'm Katie, by the way. I'm one of the GTAs for this course. We did this workshop on Wednesday, and we started off with this fun little question just to get everyone kind of loose. So I'm just gonna ask you guys, which meme from The Office do you think best encapsulates how you feel about this class right now? All right. So see if I can get this to work. Here's A. You're in love. You think physiology is the best thing ever. And you think this class is wonderful. B. You're kind of feeling a little uneasy, but it's mostly okay. Right? C is going downhill a little bit. D is a little bit lackluster. And E is you're really struggling. You need some help, having trouble motivating, all of those things, all right? So since we're a pretty small group, why don't you guys just let me know in the chat which one you best identify with. I'll give you guys a second to do that. If you guys just want to go to the chat and let me know which one, I'll give you maybe 30 seconds. All right, B until this unit. So this unit was a little bit worse, all right? Anyone else want to let me know how they're feeling? All right, so when we did this with the students on Wednesday, this is how we felt. So, not great. I was really appreciative of the one person who picked A, who really loved physiology. And it looks like some of you guys were feeling okay until this unit, and then it's kind of going downhill a little bit. Okay? So we're hoping that this workshop will give you guys a little bit of an approach to feel more confident on your exams, okay? So our roadmap for today. So first we're going to talk about exam taking strategies. So we're going to talk specifically about how to approach those really tough multiple choice passages, the questions both, and when he presents questions in a paragraph format and then gives you guys these really long questions related to that. We'll also talk a little bit about how to approach the fill in the blank passages as well, and we'll approach testing anxiety. A lot of you guys have been asking me about how to cope with this, so we've done some research for you guys. We went and talked to some different faculty members who are really good in this area, and we've come up with a list of things that will help you. And then we'll talk about study methods too. We've intentionally put study methods at the end because a lot of you guys have already had this conversation with us. So if you've already had this conversation and you feel pretty confident, you can go ahead and skip out on that part if you'd like to. But if you want to hear it again, absolutely please do. We also made a special study guide for you guys. Not a content study guide, but a guide to successfully studying for this course and any of your science courses. We put it on Canvas for you. I'll show you at the end, but it'll go over everything we talk about today with relation to study. Okay? All right, you're welcome for that study guide. So, why do we care? So this is a really important question. If you guys can give meaning to this material, then you guys will do so much better in this course, okay? Our brain naturally latches on to things that we create meaning from, okay? If we have an attachment to something, we care more about it, we learn more from it, and we tend to do better. So one of the things that I like to think about is where I want to go, okay? So I care about physiology because I'm really interested in medicine. I'm really interested in teaching you guys, and that makes me highly, highly motivated to learn this stuff, even if I'm not particularly interested in it, okay? So for example, the cardiovascular system has never been my favorite system to study. I'm a neuro girl myself, but I'm highly, highly motivated to study all of the ins and outs so that I can help you guys do better in your exams, so I can teach, And so when I become a physician, I can be a better physician. Right? So one of the things I like to think about is why I care about something. So I encourage you guys, even in the depths of this class, when you guys are really struggling, remember why you guys are here. That will hopefully help put you in the mindset that helps you be motivated to study. So I know, I'm sorry. So what I want to do is have you guys go back to this exam question. This is from your last exam. And what we're going to do is break it down for you guys, and we're going to show you how to have an approach. But I want you guys to take a look at it before we do anything and try to answer it and see what you come up with, okay? So I'm going to give you guys a minute. Don't worry about it being right or wrong. It's totally fine. If you're comfortable posting your answer in our chat, go ahead and do that. If you're not comfortable, that's okay. And then we're going to talk about how to break this down and what that looks like. So I'm going to give you guys the next minute or two to try and answer this question. All right, so I hope you guys had a chance to take a look at that. So when we did this with the group on Wednesday, we used this really fun polling system. I'm going to start using it in recitations because I just love it. And everyone there seemed to really like it too. When we did it with people, we got this kind of response, okay? Some people liked A, some people liked B, C and D no one really cared about, and there was a little bit of a question on E. So then what we did is we reworded this question, okay? So we broke it apart, Abby and I, and we figured out what exactly is it asking, and then we phrased it exactly like that. So this is the way that it reads when we've rephrased it and taken all of the ambiguity out of what it's asking. So I'll give you a second to read that. So when we worded it this way and we asked students what the correct answer was, everyone knew. There was very little ambiguity there. Ah, can you guys see the results that I'm showing you guys? Okay, can you guys see the polling, or is it just black? All right, let me go backwards. Okay, can you see the first one with the graph? Ah, sad. Okay. I'll just try to describe it to you guys then. So this is a system that we used called Poll Everywhere, and it looks like those questions aren't quite coming through. So what I'm trying to show is, can you guys see this question? Awesome. You guys are so good at responding. Thank you. So what we did is we asked students to respond to this, and 56% of the students chose A, which is the correct answer, and then a couple students chose B and a couple students chose E. But what we did is we reworded the question. So instead, what the question read was, I know you guys can't see it, I'm just going to read it to you. We reworded the question to say, acetylcholinesterase is an enzyme that breaks down the neurotransmitter acetylcholine. If this enzyme does not function, what's the result? And so what we found was that if we reworded the question in this way, essentially telling you exactly what we're asking, we're asking you about acetylcholine, or acetylcholinesterase, sorry, and we're asking what happens if it doesn't function and what the result is. And what we found is if we go back to this, if we go to this original question, almost 90% of the students chose A, which tells me that a lot of you guys understand the material, you're just not understanding the approach to the questions. So because of that, we really want to give you this approach. So our goal is to help you guys turn a complicated question like this into something that's a lot simpler. Okay. So, I'm sad you guys can't see these polls. This is going to be tricky, but we'll figure it out together. All right, so multiple choice questions. There is this 4-step approach that I want you guys to take. So I'm going to go through each step with you, and then I'm going to simplify it into a way that hopefully you guys can resonate with and remember on an exam. So the first step is to figure out what the question is actually asking you, okay? When you're given this whole jumble of words, what's the idea that you're supposed to come away with? What's the concept you're supposed to know about? What is this question asking you? Once you've figured out what the question's asking, then you can start to ask yourself, what do you know about this concept? How can you start to draw different ideas together, make this mental map, so to speak, to start to bring in some concrete ideas to this question? Once you've started to gather this background information, then you can come to your own conclusion, okay? Very important that you come to your own conclusion on these exams before looking at his answers. So one of the first things we want you guys to do back in this first step is to cover the answers. His questions can be a little bit overwhelming. There's a lot of words, and so it really decreases that stress factor if you can cover the answers and just read the question. Plus, we want you guys to be able to generate your own answers as well. And so this will kind of test your problem-solving ability and your ability to think critically, okay? So you come to your own conclusion, and after you've kind of figured out what you want your answer to be, then you can look at the answers and you can prove why your answer is right. And what that looks like is going through the answer choices and flipping it around and saying, answer choice A is correct because of this, because of my knowledge of neuro or cardiology or something like that. And I would also recommend for all of those people who really second guess themselves, a lot of students that struggle with that, go through all of the wrong answers and prove to yourself why they're wrong. I would go through, and on my exams, I used to write this out next to each answer choice, and I used to say, this answer choice is wrong for this reason. Either it's talking about something totally different, the process is incorrect, something like that. So these questions are really good to ask, but if we're being honest on an exam, when you guys are stressed and anxiety is pretty high, it's hard to remember these 4 questions in this order. So we've made it really simple for you guys, okay? So first, we want you to dissect the question, figure out what it's asking. Then we want you to brainstorm, figure out what related concepts you know, what concrete ideas you have. Then we want you to solve the problem yourself and then prove it by looking at the other answers and tying in your knowledge with the answer choices. So here's what this looks like. We start with dissecting, and we start by pulling the question apart and figuring out all of its little pieces. So the very first thing we want you to do is cover your answers. Okay, and there's a lot of answers that can be designed to mislead you. So if you're not 100% sure on, which rabbit hole you want to jump down, this is something that induces a lot of stress and makes the whole process of solving this question really, really hard. So we want you to cover your answers first thing, really important to remember. And then we want you to read the question in its entirety, from beginning to end. Go ahead and read it. That doesn't mean to keep going and read the answers, just stick with the question. And then we want you to read it again and underline the important things. If you don't know what the important things are, you can just underline the words that you know, the words that look familiar, okay? After you've underlined the important things, maybe you can cross out some information that you don't need for answering the question, like background information. Define your terms. So you've underlined your important things, now define those. And from there, you'll start to create a little bit of a concept map, a little bit of concepts that you know about. But students really take for granted this idea of overestimating what they think they know, okay? So I'd highly recommend circling those words or underlining words that you think are important, draw a little arrow, and then define them in the margin. After you've done that, I would rephrase the question in the margin. And when you're doing this, you're rephrasing it from the question that he's asking into your interpretation of it. And so you figured out at this point what the question is trying to ask, and you can start to solve it. Okay? So if we go back to this, by the way, if I go too fast at any point, or if you want me to go back, just let me know in the chat. I have it up in the corner. Also, if you have any questions, feel free to let me know. I'm happy to pause and answer those. So if we look at this question, this is the one that we just talked about. The very, very first thing we do is cover the answers. Already this looks a lot easier to digest, a lot easier to approach, right? So now what I'm going to do is I'm going to read through it. I'm going to figure out what's extra information that I don't need and what's pertinent to what the question's asking. Okay? So if I read this question out loud, a proposed treatment for envenomation by cobras is a nasal spray containing neostigmine, a drug that blocks acetylcholinesterase. You would expect this treatment to be effective because it would. So this first part of the sentence, I don't really care about that for the purposes of answering this question, right? It's not going to help me. It's a lot of complicated words, so I'm just going to take it out. Two of the words that are really important, blocking acetylcholinesterase, okay? Those are words that we've heard of before, right? You might also highlight the word effective too, that I could see as well. But now already we've dissected it into something that looks a lot more manageable. So if I were to rewrite the question, I might write something that looks like this. What does acetylcholinesterase do and what happens when it doesn't work? Okay. So now this is a lot easier to digest. This is a lot easier to approach. So that's what we're going to do next. So now we know what the question's asking. Now we're going to think about what we know about this concept. So this big picture concept is synaptic transmission, right? We're talking about acetylcholinesterase, right? And the location we're in is the nervous system. Specifically, the passage was referring to the neuromuscular junction, which is the space between the lower motor neuron and the muscle cell. Okay, so students frequently get questions wrong because they get the location wrong in the body. And this is a really simple step because you guys know this information really, really well. You've studied this a lot. I know you have. So just take a minute and think about where in the body you are and how you know that. After that, I might define some of these terms. So acetylcholinesterase, for example, this ACE at the end tells us it's an enzyme. And we know from this last unit that acetylcholinesterase is an enzyme that breaks down acetylcholine, which is a neurotransmitter, into acetate and choline. And that effectively decreases our concentration of acetylcholine at the neuromuscular junction, which is a really good thing. That's something we want. It's an important part of this whole process of activating the muscle cell. Okay. Then I'd start to come up with your answer. So we talked about what acetylcholinesterase is and what it does. So without this enzyme, it's really feasible for us to say acetylcholine isn't broken down, which would lead to a higher concentration of acetylcholine at the neuromuscular junction. So this is, again, something you can be writing down in the margins as you're working, okay? Kind of going down this flow of information, this rabbit hole, if you would. And you've come to this conclusion of, all right, I know what this enzyme does. I understand what the question is asking me. If this enzyme isn't here, something happens such that there's a higher concentration of acetylcholine at the neuromuscular junction. And now that you have a little bit of a conclusion, I would go back to this question. And I would read it again in its entirety, right? You know what it's asking you. And now you can read the answer choices. So if we look at A, prolonged availability of acetylcholine at the neuromuscular synapse, that already looks great. I really like that answer. It's very consistent with what we've talked about in our background. But one of the most important things is that I'm not immediately going to circle this answer and move on. I'm going to read all of the other answers and justify why they're wrong. Because if I've studied this material really well, then I understand it, which means that shouldn't take too long. So if I read B, acetylcholinesterase increases the availability of choline and acetate in the synaptic cleft. Well, I know that that enzyme, if it's working, does that. Because the job of acetylcholinesterase, as we said earlier, is to break down acetylcholine into those two parts. Which means that if we block that enzyme, then we're not increasing the availability of these two byproducts, we'd be decreasing it. So I can cross off B, and I would physically cross it off on the exam. If I go to C, increase sodium permeability in the muscle T tubule. Well, we know from the previous, there's a paragraph that goes before this, we know that we're talking about the neuromuscular junction, which is a totally different location than the T-tubule, so that one can't be correct. And then if we look at D, prolonging the duration of individual action potentials, well, we know that one of the hallmark features of an action potential is that it's invariable, which means it doesn't change, it looks exactly the same all the time. And so because we know that it's invariant, we can't prolong the duration of it, okay? So we can immediately cross off D. And of course, we can block off E because B through D were incorrect. So now we can, with 100% certainty, know that A is the correct answer. So this is one of the things I want you guys to focus on. So even after you guys have solved this, I would question yourself as to why does your answer make sense and why are the other choices incorrect? This is a really good way of approaching questions if you tend to second guess yourself. I fall into this all the time. But if you can come up with a reason that the incorrect answers are in fact incorrect, then you'll increase your confidence, you'll feel better as you're moving forward through the exam, and you'll hopefully do better on it, okay? Do you guys have any questions at this point for me? All right, so don't forget, dissect first, brainstorm, solve, and then prove. So, oh, you guys can't see this. I'm sad. All right, so the question on this page was, what are the stages of dissecting an exam question? Just as a review for you guys. And recall that the very first thing you guys want to do is cover your answers, and then you read the question, highlight key information, define your terms, and then rephrase the question in your own words. And again, I would physically write that in the side of on the side of the page. So if we look at another example here, okay. So if you guys want to post in the little group chat, what are a couple things you see that you think are important in this question? Some of the important things you might take out of it. I'll give you a second to read it. Antibodies and where they are. All right, I like that a lot. So when we look at this, there's a little bit of ambiguity in a question like this, and I had a lot of students ask this to me when they were taking the exam, what antibodies are and what happens when you're labeling something. That's something that's usually covered in more introductory classes, which is why Dr. Walrond feels okay putting something like that on the exam. If you don't know what that means for an antibody to label something, that's an example of something that you can definitely raise your hand and ask a GTA about, or any of the TAs in the room, okay? That's something that's not content related, and so we're happy to try and clarify that for you and help you understand what that means. So as I was reading this question, some of the things, well, first we cover the answer, most important part, right? And then we dissect. Yeah, so one of the things that I agree with that. One of the things that I found to be really important was the idea of protein synthesis, right? This is mentioned 3 different times in the span of a sentence. So if we're looking at this and we're looking at all of these different components and wondering what they mean, a lot of students get tripped up because this third word here is a chaperonin. And many of you have never heard that word before. That is a big, scary word, and we don't know what that means, right? So automatically our brains just kind of shut off because we don't know what that means. But if you keep reading, oftentimes when he gives you these new terms, he defines them for you. And so you'll find that the next part of the sentence is defining chaperonin for you. So what he's doing is, yes, he's introducing novel information, but he's defining it for you in hopes that with this new information, you can solve his novel problem that he's giving you, okay? So he gives you the idea that chaperonins function to make sure that proteins fold correctly, and this happens during protein synthesis and protein processing. So for those of you that don't know, when an antibody labels something, what happens is we attach a fluorescent dye to an antibody, and then we make that antibody very specific for a protein. And so what happens is if that protein exists in a cell and we inject that cell with an antibody, the antibody will bind to the protein and it will cause the protein to glow. And then as a researcher, we would look at that under a microscope, or we would do some imaging, and we would measure the concentration of proteins, this specific protein, based on how brightly it glows. That's essentially what that means when we label something with an antibody. So again, if that's something that you didn't know, if you're going through an exam and you don't know processes like this, you can go ahead and ask us. We are totally fine answering questions like that. If you're not sure if you can ask us a question or not, you might as well try. We're kind of bored sitting up there for 2 hours proctoring, so please raise your hand and ask us. If we can't tell you, then you will have tried. We'll tell you that we can't give you that information, but it's worth asking, okay? So now that we understand that we're really talking about protein synthesis here, we can kind of infer that what the question is asking us is, where does protein synthesis occur? Okay, so in this whole really elaborate question here, that's all we're asking. We're saying that we have these chaperones that function to make sure protein processing goes okay, and we're essentially asking where chaperones are. So now we can start to think about this stuff. So in our brainstorming, I might start with our big picture concept, which is what exactly are we talking about? And we've answered that already, protein synthesis. Again, I would go into where am I? What location is this? This was from the last exam, so we're talking about everything in the context of the nervous system. So then I might start to list out some things I remember about neurons, like dendrites and cell bodies, axons, axon terminals, right? And then we have this idea of white matter being cell processes, gray matter being the cell body, all of those fun things. I might draw a diagram. I'm a huge fan of drawing diagrams on exams. My exams used to be covered in those. Really fun. And oh, yours was decorated in all sorts of diagrams last time too. You really made our days better on those fill in the blanks with all your wonderful diagrams. Please do that again. All right, so then I would start to solve it. And I apologize, Abby, and I realized the slide is not quite right. I don't know how that happened, but we can address that as we're doing it. So then I'd start to ask, well, where are proteins made in a neuron? And I've talked about some specific parts, and we're asking where protein synthesis is occurring. So we know that proteins are, the RNA is transcribed in the nucleus, but the actual protein synthesis is occurring in the cytoplasm, okay? And we know that the nucleus where transcription happens and the bulk of the cytoplasm that we're talking about is part of the cell body, okay? So now we've come to this idea of the cell body being the location of protein synthesis. Now we're ready to look at our question in its entirety as well as the answer choices. So if we read this guy in its entirety, there are chaperonins that function to ensure the folding of proteins into their appropriate three-dimensional shape during protein synthesis and protein processing. Antibodies that label these chaperonins would be expected to be found in which of the following structures? So we already know that we're looking for something to do with gray matter, right? With cell bodies. Because we asked our big picture question of where is protein synthesis occurring, and we know that that happens in the cytoplasm, okay? And the cytoplasm is a part of this bigger structure we call the cell body. So now if we go through our answer choices, we look at A and B, maybe define these terms. We know that A, nerves, that's a bundle of cell processes or white matter in the peripheral nervous system. And we remember that tracts are a bundle of cell processes in the central nervous system. Both of these are white matter cell processes, which means that these aren't the ones that we're looking for. Okay? If we read C and D, nuclei, we remember are cell bodies in the central nervous system. And ganglia we know to be cell bodies in the peripheral nervous system. Both of these are gray matter, which makes us really like this choice of E, right? So now we've gone through these answer choices and we've essentially proved which ones are wrong and which ones are right based on our baseline knowledge of the nervous system. All right, oh, this is another poll that we did. So the question was, when should you look at the answer choices? This was trying to hammer in the idea that we want you to cover the answers as soon as you start reading the question, because we want you guys to try to solve the question before you look at the answer choices and start to feel really, really overwhelmed with all of the really complex wording that we can find there. So we want you to solve the problem first and then look at the answers. So I'll give you guys maybe 2 minutes to post any questions you guys have up till this point, any concerns that you guys have, anything that I can clarify for you, things that you want me to go back and explain again, anything you guys want. Yeah, tips for fill in the blanks. So really just a quick reminder again on these guys. We want you to dissect first, cover the answers first, brainstorm, solve, and then prove. This is a great example. We tried to come up with this in as short of a verbiage as we could so you can remember to write these in the corner of your exam. So try to do that, and I hope it works for you. So fill in the blanks. I'm so glad you asked, Katie. Oh, this is another Katie, by the way, not me. So tips and tricks for fill in the blanks. The first thing I like to ask is, what's the big picture story? We have a lot of students that get an entire fill in the blank wrong because they thought that they were supposed to talk about a different story. And it's really sad. And I'm sure very frustrating for the student who knows that all of their blanks don't quite fit, but they're just kind of trying. So I would really focus on what the big picture story is that we're asking of you. For this next exam, we'll hopefully have a bolded title for each fill in the blank to tell you what the story is. And I'm hoping that will help you guys know which rabbit hole to go down. You guys did really well with this in the last exam, though. We were so impressed. Abby suggested generating a word bank. So when you read the title of each of the fill in the blanks, to start writing down like a list of words you know that go with that. And in that way, then you can focus more on just word recognition rather than active recall and just put the words that you've written down into the blanks. That's worked for some students. You guys do this really well already, drawing diagrams. I know it certainly made my day when we were all grading your exams and there were just these beautiful color-coded diagrams on almost everyone's fill in the blank. I would highly recommend doing that. If you can draw a picture, draw a picture. And this details, this is one of the most important concepts. A lot of students understand the story we're asking them to tell, and they tell it really well, right? They've written their diagrams up on the whiteboard during their study time. They bring those diagrams to the exam, they draw it on the back, and they go through the whole story, but they get a couple minor details wrong, and it causes them to lose anywhere from 5 to 15 points on the multiple choice exam because they forgot about the context they were talking about. So as an example for you, this is an example of a fill in the blank from your last exam. And one of the things that I would like to focus on is this concept of being specific. So many of you guys, I think I stopped counting after 20 of you. Instead of writing node around BA, you just wrote node. And when we ask you to be specific, we're looking for the exact name of the thing. And that means that if you can be any more specific in your answer, be more specific. Another really good example of this, in the fill in the blank before this, we asked you to, one of the fill in the blank answers was a APSP, excitatory postsynaptic potential, and there was a be specific there, but so many of you guys wrote graded potential. And if you remember, a graded potential is the overarching umbrella term, but when we ask you to be specific, we're looking for the very specific type of potential. So that would have been synaptic, EPSP, or generator, right? So really make sure that you're thinking about, you need to be more specific, okay? And then this was the one that, oh, I'm still a little sad. So you guys read through this whole thing, and so many of you guys answered all of these correct, but you forgot that we were talking about these stretch-sensitive neurons, okay? And if you recall, stretch-sensitive neurons begin in the peripheral nervous system, right? And specifically, we're talking about the input region, so we're way out in like the tips of our fingers, the tips of our toes, those kinds of places. And down here in the bottom, we asked you to name the cell type that creates myelin, that wraps around neurons. And if you remember from your lecture, you learned about two of these cell types, right? Oligodendrocytes for the central nervous system and Schwann cells for the peripheral nervous system. And you guys know this, I know you do. And some of you wrote Schwann cells, and that was wonderful, but more than half of you wrote oligodendrocyte instead. And so it's details like this, understanding the context, misreading things like that, that tends to cause students to lose a lot of points on the exam. So make sure that you guys are going back through and thinking about the context that it's in, the fill in the blank is in. And we saw this in all three of the fill in the blanks this time, that a lot of students would have gotten 100% if they had gone back and read the context that they were in. Okay, so that's my best advice for you. When you're done filling out the fill in the blank, I would go back to the beginning and I would read it through like a story and see if each blank makes sense to the context. Okay, so I would go to each blank and I'd bring it back to the very beginning of the sentence and see if that makes sense and is consistent with your understanding of that topic. So those are my best tips and tricks for fill in the blanks. So yeah, Schwann cells was the answer for that one. And a lot of you guys did write Schwann cells, which was awesome. So many of you guys wrote and confidently wrote oligodendrocytes. When I know that you guys know that, because we've talked about it in recitation, we talked about it in lecture, and you guys teach it to me in office hours all the time. So make sure you remember the context. Sometimes students will bring like a special colored pen with them for the fill in the blanks, and they'll underline the context or they'll write about it in the corner so they don't forget. That's been really helpful for students, and you're more than welcome to bring colored pens. That's totally fine with us. So those are our best advice for the fill in the blanks for you. All right, testing anxiety. A lot of students have come into office hours to ask us about this. Yes, these exams can be quite stressful. It's really hard to be in a room with 100 other students who are all also really, really stressed. You know, you're worried about your grade and the results of not doing well on this. So what we did is we did some research, read some papers, and we went and talked to some different faculty about this. We talked to students who have done really well with testing anxiety. We had some friends provide some input from their experiences, a lot of different things. And here's most of what we came up with. So the first is the value of sleep the night before. There is study after study on the value of sleep, and it actually really impairs your ability to think clearly and problem solve if you don't sleep very well the night before. So what we're trying to say is, if you guys pull an all-nighter the night before, it's not going to work in your favor as much as you think it will. Okay, so our best recommendation is to study some the day before and the night before, but make sure you get a good night of sleep. That's super important. It turns out that when you sleep, your brain is really active, and it's actively working in memory consolidation. So all of those things that you spent, in the 12 hours you were studying the day before the exam, that's being consolidated while you sleep, okay? Which means that information that you studied the day before, you'll know it much, much better if you allow it to kind of settle in your brain, allow your brain to kind of think through it while you sleep. But if you continue studying and pull that all-nighter, you never give that information time to consolidate, which means that you now know a vast amount of information in a very shaky kind of way. Whereas if you had studied half as much, so maybe the whole day before, and then gotten a good night of sleep, you would retain a lot more of that information. Okay, so one of the biggest things is to sleep. And I know that sounds kind of silly, but there's so much research to back this up, so very much. So I'd highly recommend going to sleep. Don't stay up the whole night before. And if you need to keep studying the day of the exam, that's okay, go for it, but make sure that you guys are sleeping enough the night before. I know it feels more rewarding to keep studying, but science disagrees. So the day of the exam, some of the things that we found, maybe a half hour before the exam, closing all of your books, closing everything to do with the test, maybe putting in some headphones and going for a walk, okay? Meditating works really, really well. Let's see, Abby found some things on eating. So she talked a little bit on Wednesday about eating the day of the exam. A lot of students come to our exam and we ask how you are and you say, oh my God, I'm so stressed and I haven't eaten all day. You need to eat. Eating is really important. So we read some studies that talked about the importance of eating an hour before. That keeps your blood sugar stable, right? Maybe a little snack right before. And then reframing nerves. This is a very interesting little brain hack here, and again, some really interesting research on it. It turns out that your body's response to stress and your body's response to excitement are very similar. Now, you guys know a lot about the sympathetic nervous system right now, or you will by next Wednesday. And the sympathetic nervous system is a part of both of these responses. So one of the things that we found was that if you are nervous or stressed, but you tell yourself that you're excited, it works. And again, I know that sounds kind of funny, but it does. So Abby told this wonderful story about her experience with her first day of recitation. She was really nervous to get up in front of you guys and to teach. But she came down to our GTA office and she said, you know what? I'm going to be excited instead. And I'm going to be just really, really excited and I'm not going to be nervous. And then she believed it and she went in and she did really, really well on her first day of teaching. So I know this kind of sounds like faking it until you make it, but it actually works. So that's another thing you could do. And then during the exam, breathing deeply, taking breaks is important. You know, if you're really stressed, just sitting back in your chair for a few minutes and just trying to calm your mind a little bit. Sometimes even 3 deep breaths, taking, a 10-second break can be really beneficial for you guys. And then after that, it depends. I don't know. I think it depends on what kind of person you are. Some people, like myself, I'm very much a forward thinker. So when I'm really stressed during an exam, something that I'll do is I'll sit back and think, okay, what's the worst possible thing that can happen? And usually my answer is, well, I could completely fail this exam, or I could just start crying, throw the exam, run out of the room. All of those good things. And then I'll think about, okay, the worst possible scenario. 5 years from now, is it going to matter that I failed this exam? And almost always the answer is no. Even if that means that I would fail the exam, fail the class, even if I had to retake the class, what I'll try to do is reframe that in terms of an opportunity. I'll try to think, okay, maybe I wasn't ready to pass this class. There were skills I needed to learn, content I needed to learn, all of these different things. So even if I do fail this exam, fail this class, I have the opportunity to go back and try again and try better and do better. I will have learned and grown from it. So maybe that was a really important experience for me to have. So I don't know if that's something that would work for you, but something that's worked really well for me in the past when I've been in exams where I really didn't think I'd do well. Like the MCAT, for example, that's exactly what happened. And this last bit, journaling. Okay. We recently read this really fascinating study that was given to me by a friend of mine. It turns out that if you spend the 5 to 10 minutes before an exam journaling, it makes a huge difference. And what I mean by that is you can sit down in your chair, you can take out a piece of paper and write down the things you're stressed about and the things you're worried about. I'm not saying to start writing out the content of the exams and start, drawing your Drawing your diagrams with the sympathetic and parasympathetic autonomic nervous system. Write what you're stressed about. Write what you're scared of. Write what you're really worried about. And by doing that, you get it from your brain onto that paper. Okay, it's this very therapeutic thing. And then you can, put that paper away or give it to us if you want, or throw it in the trash. And then what they found in their research study is that students performed significantly better on their exam when they wrote down what they were stressed about in that 5 minutes before. Crazy, crazy concept. If you guys have journals of your own, you could do this in, the half hour or hour before, okay? Maybe just sit down somewhere close to your exam room or somewhere on campus and write a little bit. If you want to do that in the exam room with us next week, that's okay. That's totally fine. If you want to get out a piece of like scratch paper or something and write down a couple notes, just make sure you put the scratch paper away afterwards, or give it to us or something like that. But I'd highly recommend doing something like this because the research is new, but it's actually very, very promising. So I keep something like that in mind. You might find that it helps you, okay? Any questions on anything or anything to add? At this point on Wednesday, we had some students talk about the things that they do that really help with their testing anxiety, and it actually turned into a really cool discussion. So do you guys have anything that you want to add? Any questions you have about this stuff? I'll give you guys a second to type. All right, sounds like you guys are pretty comfortable with this stuff, so we'll go ahead and move on. All right. So it turns out that the approach that we've given you for these exam questions only works if the content has been mastered well, which means this stuff will only work for you if you know the material, okay? So our presentation was office themed on Wednesday. So if you're like Michael and you don't know anything, even if you have all of the exam strategies in the world, you're probably still not going to do very well, okay? So that brings us to this idea of studying well, okay? So one of the issues is that we have students that work really hard on remembering like diagrams and stuff like that, and sometimes working to understand them, and I love that. That would be like telling the story, stuff like that, okay? Rewriting your notes, trying to understand how different parts work. So this is how students typically study, and this is a really good start. I'm not saying that these things aren't important. The problem is that you're tested on this level. You're tested to apply knowledge and to analyze problems, okay? And you're typically not tested on these top concepts here. This is the concept of what's called Bloom's taxonomy. And the remembering and the understanding is really important, and you do have to do that first in your studying. So if you're working with those concepts, that's not a bad thing. The problem is that it's not enough for you to do well in this class, which I'm sure a lot of you are already coming to the conclusion of. Because when Dr. Warren tests you guys, he's testing on your ability to use that information that you understand and to apply it to a novel problem that you've never seen before, right? Or to analyze a system in a way that maybe he's broken it and to answer a question based on it, okay? And so one of the biggest tools that we can give you guys is to study in the same way that he tests you, okay? So rather than only studying to remember and understand, do those things, but then apply them to novel problems of your own. And this is a lot simpler than you think, so we're going to go into exactly how to do that and how to study successfully for this class. So what we're telling you is that you have to learn how to learn. It turns out that students are, anyone in the whole world, we're not born with an innate ability to learn. It's a skill that we have to refine over time, and it's really hard. And you have to work at it, and it doesn't come naturally, okay? For me, it took a long time. It took months of practice for it to really work for me, but it's worth your time. It's It's worth your time because you learn how to solve problems, how to think critically, and these are skills that you'll use anywhere in your life. It does not matter what discipline you go into, you'll use it. Okay, so it's worth your time to start doing these kinds of things. So how do you study? The very first thing I want to talk about is organizing your time. Before you can sit down to study, you have to figure out when you're going to study and what you're going to study. Okay, I hate to break it to you, but if you're sitting at your desk and you have, you know, Parks and Rec in one window of your computer and your friend talking to you on the other side, and you kind of have your notes pulled up, that's not studying. I hope that's not news to anybody, but I know some of you are doing it anyway, and I've done it too. So the first thing you need to do is organize your time and prioritize, okay? So one of the first things I like to recommend is this concept of time blocking or planning your day. In our biomedical science master's program, our director of it likes to recommend that his students plan out their day by the hour. And what that looks like is they'll physically have a block in their schedule. Most of us use Google Calendar. You can also buy really cool planners that do this for you, which is what I have. But you guys can literally say, you know, from 7 to 8, I'm going to be making breakfast and getting ready. From 8 to 9, I have class. And from 9 to 9:30, I'm going to go immediately to the library and rewrite my notes while it's fresh in my mind, okay? Then from 10 to 11, maybe you have class. And then from maybe 11 to 1, that's when you sit down in your favorite study spot and you study, okay? And I might write in my planner or agenda what topic I want to be studying or what class or something like that. And this brings us to the concept of prioritizing. So a lot of you guys are taking multiple really hard science classes right now, and I've had semesters like that too, and they are really, really hard if you don't know how to plan very well, especially when you get to exam weeks, when you have 3 or 4 very hard exams in 1 week. You know, you're taking organic chemistry exams, you're taking physiology exams, you're taking anatomy exams, and that is really hard if you're not spacing your time very well, and if you're trying to cram all of that knowledge into 1 week. So something that I like to do, and a lot of my peers in the graduate program like to do, is to sit down sometime over the weekend or Monday morning and plan out the whole week. So, and that doesn't mean that you're doing hard things all week. You plan in free time and stuff too, and time when you want to see your friends and take a break and, you know, watch Netflix, all of those fun things, climb mountains, whatever you like to do with your free time. But what that means is that you physically block out times in your schedule when you plan to be studying. And I might even add in which class I want to be studying for or which topic in the class I want to study for, okay? And so by doing that, if you stick to this schedule that you've created, now you're adding in some consistency, and there's a little bit of comfort there knowing that if you do all of those things, then you will have studied the amount that you want to throughout the week, and you'll be working through all of your classes, okay? So this adds in the idea of consistency. Consistency is really important. It turns out that cramming doesn't work. And the reason it feels like it works is because we have this idea of this short-term reward, okay? So it feels like it's working in the moment because you're reading over all of this information and it looks familiar. So you're saying, yes, I feel like I'm getting this. I feel like this is going into my head. I'm gonna do really well in this exam. And even though I've studied for the last, I don't know, 16 hours, I feel like I still have more to study. I have a little bit more energy. You know, you're running on caffeine and sugar at this point. It's been there. But it turns out that's not how our brains work. So here's how you break a graph like this up. This graph is trying to convey the idea that you need to repeat the information you study several times in order to remember it. You need to be reviewing information consistently. So if we look at this X and Y axis, it's studying the retention of material over time being days. So what it's saying is you study something once, your initial study, and then if you don't study it again in that 24 hours, then you decrease your retention pretty rapidly, right? You remember maybe 40% of the material. If you don't review it again that day, then now you go down to less than 20%. So you really aren't remembering any of it, right? But when you're studying it right in the moment, back to that initial study, you feel like you're retaining it really, really well, right? Because you're staring at the notes, you're able to, blindly recall it in the moment, right? So it feels good. But the problem is it doesn't last. So if you're doing this study on, let's say tonight, you're studying something about, let's say the immune system, and you don't study that again until Tuesday, you have essentially wasted a good portion of your time on this Friday night, because you will have retained very little of it. So consistency is so important. So look at this next curve. If you do your initial study and wait a day, but then you review it again, now you have this shallower forgetting curve, right? Which means that it takes longer for you to forget things. And then if you review it again a couple days later, then you remember even more of it, okay? And then if you review it a third time, now you remember most of it for a long time. So what we're asking you guys to do, and what I'm really encouraging you to do, is to study material consistently. Something that really, really helps with this is flashcards. So I would recommend really working to understand the material with your whiteboard diagrams, with telling your stories, all of these different things that we'll go into. But if you need a way to just kind of remind and cue your brain to remember something, flashcards do work really well. Not as a sole method of study, but just to kind of cue your brain into a topic, that might work really well. Okay. All right, so you've organized your time. You're sitting in your study room, maybe alone, maybe with people. What do you do? What do you do with your time? How do you make it a good use of your time? I'm so glad you asked. There are 3 steps. In the first stage of studying, you want to set a good foundation, right? If we're looking back at Bloom's taxonomy, this would be the remembering and understanding, right? The base of the pyramid, really, really important. And a lot of students stop right there. What we want you to do is, after you set your foundation, we want you to grow, right? Work with this material, synthesize it a little bit, and then we want you to apply it. And the reason we want you to apply it, well, one of the reasons, is that his exams are almost all application. But in addition to that, a lot of you guys are thinking of going into some kind of healthcare profession, and application is what you'll be asked to do every single day. So if you guys understand how to approach a novel problem, how to apply knowledge you have to novel situations, then you guys will do really well in a setting like professional school where you're asked to do this every day. So here's what that looks like. In this foundation part, this first step, I like to call big picture. Okay, so this is kind of setting the stage, if you would. This is providing for you why you care, what the topic is you're talking about, and why it's important to you. So in this would mostly happen with my just thinking, maybe a little bit of reflecting, a little bit of whiteboard work, but you want to keep it really big picture. So stay away from all of those details for this step. Okay. So you want to ask yourself, what is the overarching concept I'm talking about? Okay. And so if you're studying for this exam for Wednesday, you might say, all right, I want to study the autonomic nervous system. And then I might say, all right, well, what is the autonomic nervous system? Before I can talk about it, before I can dive into the details and draw the diagrams, do I actually understand what the autonomic nervous system is? How is that different from the other kinds of nervous systems that we've learned about? And then I might ask, why is this topic important? Why do I care about it? As we said at the beginning of this session, if you can bring meaning into a topic, you'll be so much better off. So I might ask yourself, why do I care about this topic? Why is it important? For the autonomic nervous system, what I like to talk to students about is the fact that autonomic makes me think of the word automatic, which is what the autonomic nervous system is, right? We can't control it, it's unconscious. It's that motor outflow, controlling, smooth muscle, cardiac muscle, glandular tissues. And one of the reasons it's important is because it's regulating homeostasis in my body, which means that it's doing a million different things unconsciously so that I don't have to worry about those things, and I can worry about things like talking to you guys right now and, using my brain and thinking about things. So it's regulating a million different things in my body so I can function. And that is a really beautiful and incredible thing. And so when I set a stage like that and I approach it with the sense of, wow, this is really incredible. This is this amazing system that is allowing me to function well and properly, that makes me really motivated to study and learn about it more. Okay, because I'm fascinated by the design of a system like that. So just as an example. So again, you're wanting to start big picture. And once you've done that, you can enter the growth phase. And this is what we like to call elaborating and asking why. So this is when I would start to rewrite my notes. This is when I would draw out my whiteboard diagrams. I would make a story out of the material. But then I would start to ask questions. And the questions I would ask would be, why does the system I'm studying have, the components that it does? And why do those components make sense, right? So instead of just learning that the autonomic nervous system has two components, sympathetic and parasympathetic, I might ask myself, all right, well, why does that make sense? If I could design a human body, why would I have both of those systems and not just one? Right? And then I might come to the answer of, well, sympathetics, is my fight and flight, ramps up my system. Parasympathetics turn the whole system down there. It's a relaxing system. And I really want both so I can fine tune and regulate and adapt to my surroundings. Okay. So I really like breaking down systems into asking why. If you're learning about, specific graphs or even specific channels, if we're looking at, let's use, actually the autonomic system comes to mind again, and this is helpful for you guys for the exam. If you're looking at those diagrams working with cyclic AMP, right? So the end result being with sympathetics, you increase concentrations of cyclic AMP to increase heart rate. Parasympathetics, you decrease concentrations of cyclic AMP, decreasing heart rate. Instead of just memorizing those diagrams, I would say, well, why does that make sense? Why do each of those components exist? And why does it make sense to me that if I change my levels of cyclic AMP, that I change my heart rate, okay? The answer has something to do with HCN channels, so take a look at that, it'd be helpful. And then you could even say things like, well, why does my concentration of cyclic AMP increase? Why does that make sense? Then you could go back in your story and say, well, when norepinephrine is released from the postganglionic neuron in the sympathetic system, right, we bind to that G protein coupled receptor, activate our G alpha S subunit. And now see, I'm kind of telling the story, right? And the answer to my asking why, right? Our alpha subunit activates adenylyl cyclase, and as we very well remember, adenylyl cyclase is responsible for converting ATP to cyclic AMP. So if you look at that whole process, what we come away with is, if you release more norepinephrine in the beginning, you end up with a higher concentration of cyclic AMP, open more HCN channels, faster heart rate, right? But now, instead of just drawing out the diagram and memorizing it, what I've done instead is tried to work through it and problem solve a little bit and ask why these things make sense, okay? And after I've done that, I'm going to start applying. And what applying really means is breaking the system. So I'm going to draw out all of these diagrams, and then what I'm going to do is I'm going to start drawing red X's through all of these different components. And I'm going to say, if I take one component out of the system, what goes wrong? What happens? What's my big picture effect? What's broken, basically? And so these are your hypothetical case studies. And I know case studies is kind of a scary word, but that doesn't mean you have to sit down and write anything or solve these massive problems. They can be pretty little. Okay, so you could just sit down and say, all right, well, what if I didn't have HCN channels? What would happen, right? Your pacemaker cells wouldn't initiate an action potential and your heart wouldn't beat, right? So now you really understand how, certain components work in a larger system if you know what happens when they go wrong, okay? And this is what we're asking you to do on so many of your exam questions. So if you're already in that mindset, thinking that way, when you approach the exam, and you'll be ready for things like that. So I'd highly recommend working with this application idea, okay? So here's some more practical things, and we've talked about most of these. But again, big picture is talking about the overarching concept, maybe drawing some overarching diagrams. The growth period is where the majority of your baseline learning is happening, right? So rewriting your notes in paragraph format, drawing diagrams on the whiteboard, story, teaching is so beneficial. Honestly, the only reason any of us GTAs know anything about any of this is because we have to teach you guys every week. It's the only reason. So if you guys can get with a group of people and teach each other, that works really, really well. Test yourself, so close all of your notes and try to recall, right? That tests something called the retrieval effect, and the more you test something like that, the better you remember things. And then I'd move on to this application part, and I would break the system. So take all of these components that you know and remove one at a time and see what happens, okay? Stuff that works really well. By the way, for those of you taking notes right now, all of this stuff we've just talked about is in that study guide on Canvas. Before we go, I can show you where that is if you'd like. So as an example, yeah, so at this point I wrote out a example for students. Actually, maybe I can just share a whiteboard. Yes, I'm totally gonna do that. Okay. Sharing a whiteboard. Yes, that worked. Can you all see the whiteboard right now? Can you just let me know that you can see that? Thank you. All right, so just as an example, I'm gonna do one from last unit just because this is kind of what I'm thinking of. So if I were to draw out, let's say, a neuron from last unit, I hope this doesn't like make you guys too sad. So if I draw out mine, this is our pineapple neuron that we used in this last unit, right? I might draw an axon terminal. Wow, that's terrible, impressively terrible. All right, then what I'm gonna do is I'm gonna start drawing in the different channels that we learned about, right? Because you guys spend a lot of time drawing stuff out like this. So I'm gonna draw maybe some ligand-gated channels here, right? And then maybe I'll draw some voltage-gated channels out here. And then maybe some leak channels. Remember that leak channels are kind of everywhere. So I'm just going to draw them everywhere. And then we have our voltage-gated calcium channels here at the end. Those are special guys. And then maybe vesicles at the end carrying that neurotransmitter. Remember that we ultimately want to release this neurotransmitter to signal to the next neuron. So I might write all of these things out, right? And I might start to, define them or at least label them. So ligand-gated channels, and then I might remind myself that there are leak channels here. And so at this point, I'm just learning what all of these channels are, right? And what they do when they're working properly. And then after I learn all of these things, I'm going to start to break the system. Because if you think about it, so many of Dr. Walren's questions, especially on this last exam, were literally just breaking the system in different ways and asking you what goes wrong. So when you're studying, what you can do, you start to say things like, all right, well, what if I didn't have ligand-gated channels? What if there was some crazy mutation and they just didn't exist? Okay, so take out all the ligand-gated channels. What would happen? Okay, and maybe with a group or by myself, I can start to problem solve through that idea and start to think of, all right, well, what would happen? Maybe the answer is, I have no idea what would happen. And then that immediately says to you, all right, I don't know this material as well as I thought I did, but now I have the opportunity to figure out what that answer is, okay? So in this example, we remember that neurotransmitters in the synaptic cleft would bind to these ligand-gated channels. They'd open the ligand-gated channels, allow ions to flow in, and that would allow for these graded potentials and then action potentials, the overall activation of this neuron, right? So if I take out these ligand-gated channels, these neurotransmitters have nothing to bind to, so this whole neuron doesn't get activated, right? And that was a question on the last exam. If I take out, voltage-gated channels, no action potential can start, right? So if I were Dr. Warren, I might say, what does the action potential look like? And you might say, all right, well, if this is threshold here, right, this is my change in voltage over time, you might say, all right, well, I can still initiate my graded potentials if my ligand-gated channels are working. If we're assuming in this example the voltage-gated channels don't work. So you might say, all right, well, I can still have my EPSPs, those are okay, but I can't have an action potential because that requires the opening of all of these voltage-gated channels, right? Which means that I'm going to try to depolarize, it's not going to work, so I'm just going to go back down, okay? So there's this whole host of questions that he could ask based on an example like this. So if you guys are studying in this way, breaking the system in all of these different ways, you're thinking in the same way that he is, and the same way that researchers all over the world are thinking, So that's how I'd recommend going about that, breaking the system, and I would do that with everything. I would do that with everything, with all of the things, as many as you can. That'll start to work on your problem-solving skills. Do you guys see the PowerPoint again? I'm trying to share the screen again. Thank you. You guys are the best. So, breaking the system, super important. Why do we do it? Most students should memorize these things and then move on. We break the system for a couple of different reasons. The first, and probably the most immediately pertinent for you guys, is that this is what we expect from you on your exam. The ability to apply the knowledge you know to novel problems. But there's so many other things too. You're developing your ability to think critically, your ability to problem solve, and your ability to approach a novel problem. And all of these skills are extremely beneficial for you anywhere you go in life, okay? And these years that you have in college, this is a relatively safe environment for you to start building those skills. Okay, so that's what we really want to encourage you guys to do. And I promise you that it will pay off in all of your future classes if you have this ability, okay? And so again, what we're trying to get you guys to do is make this leap from simply remembering and understanding things to applying in your studying. So start to make little case studies and start to quiz each other and challenge each other on when something goes wrong, what happens, okay? Again, this remembering and understanding is important, and you do need to start there, but try to take it a step further, okay? And the last thing, don't forget how amazing this stuff is, you guys. This is such an opportunity to learn about how incredible it is that the human body does everything that it does. It's so incredibly complex, and you guys get to learn about all of it. It's amazing. So I know this stuff can get really difficult and really challenging in all of its, in-depth pieces, but try to zoom out and think about how incredible it is that, your heart beats without you ever having to tell it to. I'm talking without having to really consciously figure out what I'm going to say. You can move without really having to think about it. Thousands of neurons are firing for you to be able to do all these things. You're breathing without thinking about it, digesting, regulating so many things. And that's really amazing. So I know it's kind of hard to study all of these things, but keep trying your best. Keep trying your best and keep working with this material and working on thinking critically, problem solving, all of these things, okay? All right, so that's all I have for you guys. Let me know if you guys have questions for me. Otherwise, you guys can go ahead and sign off and have a great night. Thank you guys for joining me.